This is the second episode of a short series that deals with segmentation of our network. In the first episode, we have defined the firewall and the Wi-Fi networks for our internal LAN, our guest Wi-Fi and for our IoT devices. In this episode, we will extend the three Wi-Fi networks to a second access point by using VLANs. Stay tuned. Let's quickly recap what we have on our main router by logging into the web interface, which is called luci, of our first OpenWrt router. If we click on Network, then Firewall, we can see the four firewall zones for our internal LAN, the guest and IoT network, as well as the WAN, which is basically the internet. Under Network, Wireless, we can see the wireless networks again, one for LAN, one for guest and one for IoT. Under Network Interfaces, we have the corresponding interfaces. What we want to achieve in this episode is that we want a second access point with the same Wi-Fi networks, so LAN, guest and IoT. But we do not want to set up the whole firewall settings twice, but rather use the main router as a firewall. IP addresses should be given away by the primary router for all devices, regardless whether they connect to the Wi-Fi on the primary router or on the access point. Also, if we want to use fast roaming, then the second access point should be transparent from a layer 3 perspective. It should be in the right subnet and not act as a router, but rather a so-called dump access point. Okay, we will hook up the second access point to the first one with Ethernet cabling. Hence, we need to add Ethernet interfaces to each of those firewall zones. Now, unfortunately, I only have one Ethernet interface in this router. So how am I going to achieve this? My first attempts to do this before I knew how to use VLANs was that I tried to do this with routing. Knowing that my firewall zones and my different Wi-Fis have different IP address ranges, I tried to use firewall traffic rules to only allow traffic from one specific IP address range to a certain interface or zone. But this concept has two big flaws. First, everybody could give themselves IP addresses out of a certain range and hence move from one zone to the other, just by changing their very own IP address. Second, how am I going to do DHCP? At the moment, when I request an IP address from the router, I do of course only have a MAC address. Now, I could certainly configure fixed IP addresses for given MAC addresses. In other words, give IP addresses out of the LAN or IoT zone to the well-known MAC addresses of the LAN or IoT devices and give a guest address to everything else. But this also has a big flaw. It would mean that a device with a certain MAC address would always be, for example, in the IoT zone, regardless whether it would be connected to the IoT, LAN or guest Wi-Fi. So there is no point in having different SSIDs really. The problem needs to be solved one layer deeper, on the MAC or Ethernet layer. Let's first solve this with three separate Ethernet cables. First, I need some more Ethernet interfaces. I only have one physical interface, but in Linux, you can kind of split a physical interface such as Ethernet 0 into many virtual interfaces. These will be called Ethernet 0.1, .2 and so on. We will effectively create VLANs. In OpenWrt luci, the VLANs are created under Network, then Switch. For this, you want to make sure that the checkbox that says Enable VLAN functionality is checked. Now here we can see that I already have two VLANs. VLAN 1 is the LAN and VLAN 2 is the WAN. I need two more of those, one for IoT and one for guest. So let's do this. I need to click on Add VLAN twice. That adds VLAN 3 and VLAN 4. Behind the scenes, that actually creates the virtual interfaces Ethernet 0.3 and Ethernet 0.4. Now let's just make sure that each of those newly created Ethernet interfaces gets a port on my router switch. This can be done by assigning the VLAN to the corresponding switch port. I can only assign one interface to any single given port. So one port can only be served by one interface. I set the LAN 1 port to be served by Ethernet 0.1, which is VLAN 1, which is my LAN. Assigning a port to an interface is done by setting it to untagged. In Cisco vocabulary, this would be a source port. Let's do that with the three VLANs. The CPU needs to be set to tagged on all VLANs. That's just by design. Make sure that you don't assign your WAN here, which in my case is VLAN 2. That should only be assigned to the WAN port. Cool. So now I have 4 Ethernet adapters, and each of them has its very own connection at the back of my router. Next, I want to bridge each single one of those with the corresponding Wi-Fi. I will later do the same thing on the second access point. But let's first bridge the Ethernet and Wi-Fi interfaces on the main router. We go to Network, then Interfaces, and we go through all 3 interfaces and bridge the Wi-Fi and the Ethernet. LAN with Ethernet 0.1, IoT with Ethernet 0.3, and Guest with Ethernet 0.4. Save and apply. Once we will do the same thing on the second access point, we could then connect the 2 devices like this. 3 Ethernet cables or 3 different LANs for each single Wi-Fi or firewall zone. 1 cable for the LAN that will bridge our LAN Wi-Fi and our LAN Ethernet on both sides. Same thing for IoT and Guest. So Guest Wi-Fi with the Guest Ethernet, the LAN Wi-Fi with the LAN Ethernet, and the IoT Wi-Fi with the IoT Ethernet on both sides. If a device logs into the Guest network on the access point, it will then be bridged over Ethernet to the Guest interface on the router and receive an IP address from the Guest range and automatically be in the right firewall zone. Same for LAN and IoT. Now, one thing is very annoying here, and that is the fact that we need 3 cables. But I only want to use 1 single Ethernet cable between the router and the access point. What we need to do is use a trick, and that trick is called tagging. In Cisco terminology, this is called trunking. Think of tagging like a little post-it that Linux puts on each of the data packets. Hence, each packet would be clearly marked or tagged for a specific LAN or rather VLAN. A normal network device would not know what to do with it. It would discard the packet. A VLAN-aware device, such as our access point, can read the tag, remove it, and dispatch it to the corresponding interfaces. So rather than using 3 cables, each of them being untagged, we use 1 single cable and tell the other side which virtual cable or VLAN the packet belongs to by tagging it. So let's go to our switch configuration and assign a port to all 3 VLANs, but this time tagged. In the next step, we will do this on the access point on the other side and connect the 2 using the tagged ports. When a packet comes in here on the access point, let's say to the Guest Wi-Fi, it will then be delivered to the untagged Guest VLAN port on that side, but it will also be tagged, then transferred over the cable to the router, where the tag will be read and removed, and then the packet will be dispatched to the right interfaces. So having a tagged port is as good as having many untagged ports. We have just put 3 cables into 1 by using tags. Very much like IP routing on layer 3, but 1 layer below. Awesome! Now let's set up our access point the same way, but without firewall and routing, just bridging. In other words, it will be a dumb access point. In essence, what I did here is that I created the same interfaces on this side, but I set the interfaces protocols to DHCP client. Also, I disabled DNS and firewall. If you want a detailed walkthrough, then please watch my video on fast roaming. So on our access point, we have the Wi-Fi interfaces which are bridged to the Ethernet interfaces, which are then mapped, tagged to 1 port on the switch. This is the port where we connect the cable between the 2 routers. Now let's go and test this. I want to quickly switch off the Wi-Fi on my main router in order to make sure that I only connect to the second access point here. First, let me connect to the LAN Wi-Fi. I check the IP address, It's in the LAN range. I can serve the internet, and I can connect to the router. Then connect to the guest Wi-Fi. Check the address. It's in the guest range. I can serve the internet, but I can't connect to the router. Next, let me connect to the IoT Wi-Fi. Here we go. Address in the IoT range. I cannot browse the internet. I can, however, access the router. Awesome! All working as expected. So are we done? Not quite. We have one little cosmetic failure in the concept. Let's assume the following. The two OpenWrt systems are most probably not connected directly with a cable, but rather over a switch. And all your other network devices are connected to that switch as well. Now, the connection from the router and access point to the switch is tagged. And that means that if you use a managed switch, then you need to define the ports where the OpenWrt devices are on to tagged on VLANs 1, 3 and 4. And also set all other ports of your switch to untagged on the VLANs that you want to serve. Most probably, the majority of us have an unmanaged switch. And that means that all of a sudden your router has become invisible on the Ethernet network because it only sends tagged packets. Now here again we may use a trick. And that does not necessarily work with all hardware. Remember that we can only set one VLAN to untagged on an interface. In fact, OpenWrt allows you to mix tagged and untagged. So what we do is that we set the VLAN 1 to untagged and the other VLANs to tagged. This way we can still transfer all three VLANs over one cable, just the difference is that everything that is not tagged will be interpreted as VLAN 1. On the managed switch, that would be the PV ID of that port. That's it. Save and apply on both sides and we are done. Perfect! We have successfully segmented our network into 3 firewall zones. We have 3 Wi-Fi SSIDs for guests, for the LAN and for our IoT devices with adapted policies. We have added a second access point and mapped the Wi-Fi connections over one single cable using VLANs. Guys, that concludes today's episode. If you are having trouble with this, then let me know in the comments or join my Discord server where I am available for text, voice and video chat. Voice and video every Sunday at 9 AM and 6 PM Berlin time. You may also contact me on Reddit or on Facebook. Until then, many thanks for watching, liking and subscribing. Stay safe, stay healthy. Bye for now.